everybody's who's in again. All right. Next session will be mostly technical about integration of Heketi functionality into GlusterD 2. So you've heard about GlusterD 2 before, but before getting into the details, I mean, who's here? My name is Michael Adam. So I said hacker. Well, at least Rick is trying to make me not do useful stuff anymore, but I still try to contribute code here and there. So I'm part of Red Hat's container native storage engineering team. I'm leading it, and we have with me on stage Raghavendra Talur, one of the main developers, and we are going to present a couple of our ideas. Nothing of all these things is completely fixed, so it's also points of discussion. And with that, wait, I'm going to hand it over to Talur. Do you want to use this? Okay.
Thanks, Michael. Yeah, so let's have a brief look at agenda. We will be talking about GlusterD.next. So this is the original set of requirements that the community got from, the community gave us. So this is not GlusterD.2. We already had a talk on that by Kaushal. Then we'll be looking at how Heketi came about, what features were important to Heketi when it was written first, and what got added to it next. Then obviously the topic of the title, which is what features of Heketi are we trying to migrate to GlusterD 2, what's the right place to bring it in, should it stay outside of GlusterD 2 or should it be inside, and what are the trade-offs involved there. And there is a proof of concept demo which we have. Obviously it's not a complete code, but something works. It's part of GlusterD 2, and it's the feature which we are trying to migrate from Heketi to GlusterD 2. Okay, so when we ask community on what features they need in GlusterD, in the future GlusterD that we are going to write, we got many requirements. These are the 4 which stood out for me from management perspective, and which overlaps with what we have in Heketi as of today. So obviously the first requirement was for something REST API. We have seen how much the infrastructure tooling has changed over the last few years with Docker, Kubernetes, and everything else. It is necessary that more tools talk to each other and have a better contract between them. So CLI does not cut it out at that point. We need a REST API for that. If you have been following emails on GlusterDevel and users, this suggestion always comes up. The second one, where someone says, why don't you abstract bricks and provide volumes as the smallest unit? So you can find mails since 2012 or even 11 that we have been getting such a requirement. So there was one user who said, hey, I want dynamic replication to happen. I will give you 4 nodes and you do replica 4. Once the data is so much that it can't be done as replica 4, you automatically convert it into replica 3, and then you keep going down. So there were many such requests. Again, this falls into domain of automatic management, which is what GlusterD should do. Next, easier and safer management operations. I can't stress enough of it. This is the #1 ask from every storage admin that we have for GlusterD and as well as for Heketi. They want all the admin operations to be one step. They want it simpler, rebalance, self-heal. As of today, they are all about 8 or 10 steps each, and with a high chance of going wrong. If they miss one step, we are looking at data loss. Even Vijay mentioned it today in the morning's talk. So that is one thing we need to look at. And obviously better integration with other tools. Whatever is not a Gluster project, like Samba, NFS, Ganesha, or Swift, we do loose coupling there, and there is a scope for improvement. So yeah, these were the original requirements which came in. Now we'll move to Heketi.
Okay, yeah, thanks. Before moving directly to Heketi, this GlusterD.next was like a set of requirements or asks that had been collected from the community. Now, at some point, people started to talk about the GlusterD 2 project. And what we're looking at here is not the full scope of all these ideas and so on. Not everything that Kaushal has talked before about today, but only stuff that is about this volume management aspects. And there were concrete designs and ideas for the API and how to implement these disk management features. So this high-level thing was also mentioned in Vijay's presentation earlier today with one of the weaknesses, right? I mean, look at that awful command of creating a 4+2 EC volume, right? I mean, you have to name all the bricks and stuff. It's error-prone. So we want to just say, hey, certain size and go there. Create it for us. Figure out the details, how to allocate these bricks. So the ideas were already there. I've talked also, I mean, quite a lot about this with Jeff, for instance, who was, I think, one of the creators of the original ideas and plans. So, yes, and this GlusterD 2 project was kind of being talked about and created at some point. But then something else happened. What happened was that roughly at the same time, so if the dates are wrong, let me know, but I think it was sometime 2015 when people were a little more concretely talking and starting to hack on the GlusterD 2 project, right? I think the Barcelona springtime 2015 first Gluster Summit is when there were the first presentation about GlusterD 2 really.
GlusterD 2 was still in concept phase, whereas when Luis came in and started with the implementation.
Exactly, so that was concept. And then something else happened. It was Luis Pabon, who was at the time working in Red Hat. He started at roughly the similar time a separate project. Here, Heketi project. Heketi is apparently the Puerto Rican language word for one, for want of a better thing. So in hindsight, it probably should have been called put under the Gluster organization in GitHub, whatever. I mean, errors have or false decisions have been taken, but this is how it got started. And so this project implements several of the ideas of that higher level disk management that came out of the GlusterD 2 concepts. And it was a year later, in mid-2016, that thing was put into production. So it was due to that more narrow scope that it was able to move forward pretty fast. Shyam, you had a comment?
So, Heketi originally was not only for Gluster, and it was kind of not under that ambit. Just more
that's right. Luis came originally from OpenStack, and he thought about the Manila integration at that point. So anything that could consume these volume offerings, volume management offerings with the REST API would be a potential candidate here, right? So, anyways, during the course of that year, the target shifted, and we were putting it into the container land, basically. And we were putting it into production, creating versions upstream, and even putting it into a product with Red Hat. So you see, so one point is the development that was very important here. Instead of hanging on the Gluster pace and schedule for developing, releasing stuff, this was taken out, and it enabled us to work with the pace of the Kubernetes and OpenShift environment to be with their clustered container orchestration offering. So that was actually a good aspect of that separate project, which was not under the regime of Gluster engineering. But and it also, you can see in that time, I mean, this is the current state. It's mostly written in Golang. It's roughly 25 to 28,000 lines of Golang code, not very much. More than half of this code is test code. So it's not only fairly small in scope and in code, but it's also well tested. So there's a lot of unit functional testing, integration testing, all that kind of stuff. So even though the designs may not be great in all aspects, it's rather stable. Okay, so what does it really do? it implements this RESTful API, at least for those few operations that we implement, right? Hey, that's one of those GlusterD.next requests. It hides the volume create complexity because you really only specify, I want a certain so-called durability type, for instance, 3 replicas. I don't care about how many replica sets, a distribution factor, I don't care. Figure it out for me. Just size and what kind of thing. Then it goes and figures out all the disks for you. So that complexity is hidden. So the disk management feature and volume high-level thing is in there. That was the second request of GlusterD Next. It implements, as of newly, right? I mean, this was not there originally, but then over the course of the past year, we have implemented these higher-level day 2 operations. You can go to the Gluster guide and read instructions on how to replace a brick. You can read instructions how to replace a node in a cluster. Right? This thing is just single command with Heketi, but all in with certain restrictions. It manages multiple clusters. That's just a byproduct of limited scalability. So that was one of our ways to go to a higher number of volumes altogether. And it allows for one more thing, actually, because it does the allocation and distribution of space over the disks different than an administrator would do. It effectively implements this N+1 scaling that Vijay has also mentioned before. Because, so what does an admin do? You have like replica 3, you have 3 nodes, you consume, or you have 5 nodes or whatever, but you would consume, so you stay sane, right, with all these difficult commands. As an admin would go and consume all the 3 first nodes. So you need 3 more in order to create more volumes. With Heketi, it's more or less distributed across all available nodes. So if you have 5 nodes, you can create a lot of replica 3 volumes that are distributed somehow across these things, more or less homogeneously, and then you add another node. Early enough, you get more space, right? So it's not the full meaning of that N+1 scaling, but a certain way towards it. So this is some of those weaknesses are even addressed. And we as the people working on Heketi actually like to see it as part of Gluster, even though it's not under the Gluster organization. So it's much more part of Gluster than of anything else. It's exclusive for Gluster. It probably should be moved under Gluster on GitHub. We have been starting to talk about that. So how does it actually work? Just very briefly, we have the RESTful API. It's also, by the way, it has a CLI, but the CLI just calls out to the API. So there's this middleware layer. We have the so-called app inside here, and the main thing is it maintains additional state about the disks and volumes and bricks that it stores in this DB, in this database. Then we have executors. In our case, it's an SSH executor. It just SSHs into the Gluster nodes to execute these commands. So all this like volume, Gluster volume create, blah, 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 gazillion of bricks mentioned. This is where it's executed. And how, here's the logic. In the allocators. The allocator arranges the disk devices available in the various nodes, makes sure that in one replica set, all the bricks are in different failure domains, etc., etc. This is the logic where this is happening. So this is like the overview diagram. Here is a very, let me check, time check. Let's move on. This is a little bit detail about how this ring allocator works, but I think Luis has presented on that last year, so let's move on. And just say, hey, it's not all golden, there are some trade-offs. So I mentioned additional state to Gluster. That really sucks, right? So if an admin goes and does some Gluster volume modify commands, we are screwed. So once you can only initially create the cluster with Heketi and then work on it only with Heketi commands. If you modify the volumes currently with Gluster commands, it's screwed. So that means we can't do any brownfield existing cluster things. We want to do that, right? We can't mix CLI operations of Gluster and Heketi CLI. Ooh, that's bad. So, I mean, it's really special. Whenever there's a feature in Gluster that we want to expose in Heketi, we need to basically have a second engineering effort to implement that in Heketi. It's because it's not part of the core Gluster. It's not distributed. It's a single point of failure if you deploy it in the Kubernetes world. Kubernetes makes it highly available, so it's not a big problem, but still people have complained about it. And of course, because of the history, maybe, right? I mean, ideas coming from GlusterD 2 were taken out, somebody put it into a separate project, even not under the Gluster organization. I think there's low acceptance in the Gluster community, so nobody except for the like Kubernetes people actually really use it, I think. But we want to fix that. So most of these problems come from the fact, or stem from the fact that this is not part of core Gluster, not of the community, and also not of the code. So how to go about it? And with that, Talur will continue.
Okay, so if we were to bring in some of the features of Heketi, at least those which are related to disk management, into GlusterD 2, how would we go about it? When we asked that question, then these were the three main points which came about. One, volume create should be transparent in the sense that whether I want to create a volume in the traditional way by specifying the bricks, or I want to create it in the new way by specifying the size, it should both be seamless and use the same method to do that. So that's the first main requirement. It ensures backward compatibility. The next one is mainly a solution to the problem that we spoke about in the previous slide. We have to reduce the engineering effort that is required to bring in a feature. So if we somehow use the right infra in GlusterD 2, then probably the development effort required for adding a new type of a volume or new type of volume option won't require as much change in the part of the code that Heketi would bring in. There's the second one. Third, this came about because we are also talking about new features like brick splitting, where again, GlusterD will be responsible for creating bricks, but for a different problem and as a different solution. Whatever we do here should not inhibit from such new features coming in. So it should be flexible enough for those features like brick splitting to work. With these requirements, this is what we came about with. So if you visualize all the features of Heketi, you can classify them into two main categories. One is the box which is shown on the top, which is the multi-cluster management and the interface that Heketi has for Kubernetes or OpenShift and stuff like that. Yes, that's the one on the top. And the second box would be what's shown inside the Gluster core here, and that is the disk management part of Heketi. So disk management is very tightly coupled with how Gluster visualizes bricks. So it should become part of Gluster core. This is the new design. We have already seen the other two projects being mentioned here, Tendril and gdeploy. They also help in cluster management, either in the original deployment or day 1, day 2 operations. The idea is disk management is so critical and so integral to how bricks work that it should be part of the GlusterD core, and all the other projects external to it should use the same interface that GlusterD would provide to use them. That would keep the consistency that we need.
Maybe just adding one sentence to make it perfectly clear, the situation right now and in the past 1 to 2 years was we have this higher level piece, Heketi, sitting on top of Gluster, but those other projects didn't use it, right? So they had to start re-implementing stuff we already had in Heketi. So we want to draw the line and make it really everybody outside uses the same core APIs, consistent APIs. This is, I think, crucial.
Yep. So a little explanation into the GlusterD features, GlusterD 2 features that we'll be using to get this done. So apart from the core code of GlusterD 2, it has two infra frameworks. One is a plugin, and the other one is middleware. Middleware, as you might know from the definition of it, it will allow us to add more interceptors to the requests which are coming in, and we'll be able to handle the request before it is given off to GlusterD core. That's what middleware is going to do in GlusterD. And plugin comes with two sub-features. One, it will be able to provide more transaction steps. For example, Arvinda has already sent a patch for georeplication. So georeplication as a feature is external to what the GlusterD core requirements are. So he has sent a patch which demonstrates how a plugin could provide its own transaction steps, whether it is to create a GRF session or to do something else. So that's one sub-feature of a plugin. The other one is, yeah, I'll explain that as part of this diagram. So this is a very crude diagram which we did about 4 months ago, visualizing how this would probably work. So a volume create request comes there at the top one, and there is a Heketi middleware which intercepts that volume create requests. It looks at the request and it checks for, say, volume size key. If it finds a volume size key, then it means it is responsible for creating the bricks which matches up to the volume size. It uses the transactions steps that Heketi plugin provides and executes them on all the required nodes. So if it's replica 3, it will select intelligently the 3 nodes of the cluster which will host those bricks. Once that transaction is complete, the control again passes back to Heketi middleware, and then the volume create request is modified. It will now have the bricks that we created as part of our transaction. This modified volume create request is now sent to the GlusterD core part. GlusterD core will again make a check here to see that the volume create request is matching to whatever the standards that GlusterD core is using. And if it fails for some other reason, then it will reject it. If everything is right, if the user provided rest of the content which is as per the volume create requirement, then GlusterD core does its own transaction to create the wall files using wallgen, and the control again goes back. Even on the response path, the control comes back to our middleware, and we can make a note of whether GlusterD was successful in creating the volume or not. In a failure case, if volume failed to create because of some other reason, middleware will now have opportunity to again call into the transactions and clean up the bricks that were created as part of the creation step, because the volume is now, volume creation failed. So yeah, this is how it is supposed to work. And I have a prototype code now which works as per this design. Yes, Shyam.
I go.
The request which starts this whole thing is common between wall create and wall create with size.
Yes.
The REST API that is
Yes,
common.
the API is the same. Handler is coming from the middleware which will intercept it. So yeah, it's the same URL for both.
Okay.
Yeah, we will do that in the demo now.
So basically, the idea is to have the same request, and depending on what the input parameters are, you either go directly to the lower level that's already there, or you let Heketi do the preparatory work and then prepare the lower level thing. Okay? Yeah.
Okay, so I have a 3-node GlusterD setup now. Yeah, thank you. Okay, so this is a 3-node setup. Let us quickly add, just a minute. Okay, there are lot many commands here, and it's a live demo, so let's see how it goes. Okay, added 2 peers. Let's see if both of them are added. Okay, so this is the peer list. Yeah, this is GlusterD 2. We are using GlusterD 2 here. Peer list shows all the 3 nodes. We print the self ID also. So this. Yeah, so here make a note that I'm using the 24,007 port that GlusterD 2 is using. This is what Kaushal showed us in the morning. And let us get the UIDs. So we will need this for all the further commands that we have. So just, okay, have that in the environment. So this is the demo of plugin now. What we want to do is we want to talk to the server on the same port, on the same IP, but tell that this is particularly for Heketi now. So this URL determines that the rest of the content goes to the Heketi plugin, which is part of GlusterD core, part of GlusterD 2. And let us add a device. So the device is added. This is the output. Device name is shown here, and the device state is enabled. Let us do that for 2 more devices. Okay, so next, if the plugin worked, then we expect the devices to be prepared as soon as they are added. So let us see what VGS does. Okay, so we added 3 devices. We have created VG out of them. So it's the same on the PV side, 3 PVs, 3 VG. And when we create a brick, then the actual LVs will be created as per the size of the brick which comes in. So the plugin seems to work. Next, we will create a volume. So I have a template for volume create with size in it instead of the brick list. Copy back the template because I have to write the UIDs into them. Yeah, after this. Okay, so replace the IDs. Next, let us try creating the volume. Okay, so this is the thing. So if you see, this is the only line which is added to the volume create request as we have to GlusterD for GlusterD 2. It is mentioning size. And observe the path of the brick here. It's export brick 1 data. We will come back to it after the volume create is done. Okay, let us try creating the volume. Okay, the volume is created now, and let us look at what bricks were used to create the volume. So this is different. The brick paths shown here are different than what was given in the volume create request. So as of today, because I did not have enough time, I was not able to get a code which has no bricks in the create request coming in, but we still look at the size, and if size is mentioned, then this is ignored, and we replace it with whatever is coming from the plugin, which has a note of all the devices that were added to Heketi plugin. So yeah, this is how it is. It works as of today. So what's the success part? Success part is what infra that GlusterD provides as of today in form of plugin and middleware is sufficient for us to implement whatever feature of disk management we have in Heketi. So that's good. It works. All we need to do is to think of a better allocator if we can than the ring allocator what we have in Heketi, improve it, make sure that it would work with what brick splitting is going to bring in, and any other improvements. Yeah.
One more thought. Yeah, I mean, this is of course a POC, and you have heard about GlusterD 2. GlusterD 2 has still some way to go before it's really out there in production for a full replacement of current GlusterD. So that means for us, as I said earlier, we have since over a year now, we have this Heketi thing in production. So for us, it means for quite some time, we will need to continue developing Heketi as it is, improving it even. We have a lot of feature requests coming in from the very fast-paced world of Kubernetes and containers that you will hear a little more about tomorrow. So we will have to, at some point, this is a possible future, right? I don't know when it will be in the code, in the upstream, and in releases and in downstreams. Sometime next year, maybe, right? So it's one possible future, but we will have to, Heketi will have changed by then. So we will not stop working on Heketi, but this POC shows how it could be moved, these logics could be moved into GlusterD 2. I think that was it, right?
Yeah, one last point about the modularity of GlusterD 2 that we have today. So this is the Git show for all the code that has gone in for this POC. And you can look at the output. Most of the code change has gone into plugin/Heketi. And the only change I had to do was in servers rest, 3 lines of change, 2 lines of change in plugins.go, and 3 lines of change in volume_create.go. That's it. So for anyone who wants to extend capability of GlusterD 2, this is awesome. By doing 7 lines of change in core GlusterD, you can get in a new feature. So please do try. There are many more features which we can bring in using the same modularity.
These are the first plugins they might. Yeah, ideally, the changes that you would need to make to GD2 core would be 0. But since these are the first plugins that we're implementing, there are lots of things that we need to build in. But once all of this is in, and the next future plugins will not do anything. It will just be one new directory or probably some hosted elsewhere that we can pull in. Thanks.
Any questions?
So you've mentioned brick splitting a couple of times in here, and some people in the audience might be unfamiliar with it. Can you just elaborate a little bit on what that is and how it relates to N+1?
Yes. Anyone else wants to take that? Okay. I'll still try. So one of the major problems, as we have seen, is with expanding a volume or creating multiple volumes with a limited set of nodes in the cluster. Then if you have if you have a 3-node setup with each node having 3 disks, there is no simple way for a user to do any operation or make space for new volumes that they want to create. And this is the challenge that which we were looking at. And then brick splitting is this idea where instead of having the 1 GB or 2 GB or whatever is the size of the volume which determines the brick size, we always create bricks which are smaller in size, and then rebalance in backend will always know how to make free spaces by migrating smaller bricks from one node to another. So by abstracting the size of the brick and where they reside, GlusterD will be in a better position to create free spaces on the nodes required, and by balancing out the free spaces.
More on brick splitting specifically. So one thing what I realized from the community and last 10 years of GlusterD is people have a hard time understanding bricks because it is very specific to GlusterD, right? So as a project and all that. So the more we stress on brick and focus on development requirement to understand what is brick, the harder to get new members. So ideally we have to focus on only nodes, as in a machine as a end for all these commands. Oh, you just bring nodes to the pool and that should be it. Everything else should be managed by intelligence layer like Heketi and whatnot, whoever brings it. Like, oh, your brick management is a job of the tool. You should not be bothered on it. It should be monitoring what is the status. It should start replacing, like what Richard said, right? So today, it's like brick management is hard. How do you scale all these bricks? If you have to do this like in the command today, it is like a nightmare. Now features like that can be coming as a plugin here. It is like much easier to manage for a sysadmin. So that's the goal. I would say it is a focus towards more of focusing, like admins only dealing with the node level and everything else dealt in the automated way.
Okay. Any more comments or questions? This doesn't seem to be the case, so thanks for your attention, and on the next talk.